And I'll move all your faces so that I can't see you on here. I can still see you on my other screen, and I'm going to open up chat on my other screen. So realize that if you message me, you need to message, I mean, hopefully you just message everyone because it makes it easier if you message everyone. But if you're messaging me individually, you would need, like if it needed to be private, message the Melissa Kleiss IV and not the just Melissa Kleiss, because on my other computer, I have the Melissa Kleiss IV is the one I have. But messaging everyone is a good idea because then you all can read it. It makes it a little bit easier. So today's objectives. Today we're going to look at section 3.1. This may or may not be a fairly quick lesson. I can't remember, but it may or may not be a fairly quick one. At the end, I'm going to go through a couple of problems from the 2.1 and 2.2 homework. I know a lot of you already turned it in, but if you didn't, it'll be helpful. Because there's been a couple of questions that have come up numerous times. So I'm just going to jump into them and go over them really quick. I'll do that at the end. So today we're going to do 3.1. We're going to talk about the arithmetic mean and talk about the median and the mode. So those are measures of central tendency. So those are measures of center, different ways that we talk about averages or the center of data. So that's what we're going to do today. Usually we have like parent-teacher conferences that come up on the Thursday of the second week of class. And so I covered 2 different sections in one class, but I don't have that this week. So we may be getting off pretty early today, which nobody's going to complain about that. All right. So this is section 3.1. It says it right there. So we hear average all the time, and all of us know in our head how to calculate average, but average can mean different things. So measures of central tendency, they're just different ways to describe the average or the typical value. So we're going to look at 3 different ways. 2 of them are pretty useful. One is kind of useless, not completely useless, just not super needed, not used frequently. So when we talk about the word average, we hear things like average miles per gallon. We talk about the commute time to work. We talk about average household income, average height. I had no idea that the average American woman is 5'4", but I thought it was more like 5'6". So I don't know if this is true or not, but this was in my PowerPoint when I got it, and I didn't change it. This came from our textbook, but I didn't know that. Apparently I'm below average in height. I'm really short. You just can't tell because I'm on the computer screen. But I thought the average was like 5'6", but whatever. So I'm going to move on. So the first one we're going to talk about is the arithmetic mean, or you can just call it the mean. So this is the one that's most commonly referred to as average. When you just add all of the numbers together, all of the values, then divide by the total number of observations there are. So this is the one that we grew up knowing. We all know how to do this, I hope. We've been doing this for years. So you just add them all up and then divide by however many there are. So the population arithmetic mean is pronounced mu. You'll see this symbol right here. It is a mu. My mu is really ugly. When I draw it, it looks like that. And it gets messier and messier the more I draw it. This is using all of the individuals in the entire population. And the population mean is a parameter. Remember that parameter refers to population and statistic refers to sample. So the population mean, if you're referring to the population mean, you will use the mu. The sample arithmetic mean, so if we are finding the mean of the sample data, we'll use X bar. So it's this symbol right here. This is X bar. It does not have as fancy of a name as mu, and it's kind of ugly, just this little X holding a 2x4 over his head. It's just X bar. The sample mean is a statistic. These two things are calculated exactly the same way. It is just a different symbol based on whether you computed a sample or a population. So they're computed exactly the same way. They just have different symbols. I'll give you a second if you're writing stuff down.
Thank you.
You're welcome. And if I move too fast, you just tell me, say, hey, go back to the last slide. Or Clyde, slow down. I will slow down. Sometimes I get excited about the math and I will sometimes I just get excited and I'm like, I just want to keep going because I really like the math. I'm weird like
Is
that.
there a button on the keyboard where you can type in the mu? Or is that just in like our open math?
Yeah, there will be a symbol, or you just,
Right.
I usually just spell it MU.
Yeah.
I mean, even
Okay.
though it's pronounced MEW, I would just spell it MU.
Oh.
Yeah.
Okay. Mu, not like a cat meowing. Mew, mew,
It is pronounced Mew, but
mew.
I would not be upset if you spelled it either way. Like, for
Okay.
example, if you're taking a test and you type it in MEW, I'm not going to be upset with you. And it is there for, like, if you're inserting an equation. So if you're in Word or in PowerPoint and you're inserting it using the equation editor, there is a mu there. And you can also create the X bar there. Also and I don't know if you all knew this, but in your messages and in the discussion forum, you can turn on an equation editor and you can type all the fancy symbols.
Okay, very
I
cool.
could show you all how to do that at the end if you'd like. It might make things a little bit easier for you. I'll show you how to do that. Okay.
Okay.
All right. Can I move on now?
I think so. Eddie just joined us and he said his audio isn't working.
Again?
So hopefully he's caught
Okay.
up with this, writing down whatever he sees here.
He must have been the one that turned on the closed captions. I will try to speak clearly so you can see what I'm saying. Hopefully, if that doesn't work, you can go back and watch the video. Right, let's move on.
Okay.
All right. So this right here is, you're not going to have to write it this way. Using summation notation, this is how you would write the mean. And I love summation notation. I love what this looks like. But if you don't know what summation notation is, then don't even worry. So just add all of the observations together, divide by the number that there are, like the total number of observations you have. So if you had 15 things, you would add all 15 things together, then divide by 15. If you get a decimal answer, we round to one more decimal place than your raw data, unless I tell you to round to something different. Just round to one more place than your raw data. So if your raw data is all whole numbers, round to the nearest tenth. If your observations are all tenths, round to the nearest hundredth. So whatever your observations are, one more than the decimal place. There's not hard and fast rules on where you should round numbers to. This is the thing that's difficult about stats, is that every single thing we do has a different kind of way we do it. And there's not really a whole lot of rhyme or reason to it. So I'm not going to be a super stickler unless I specifically say round to the nearest tenth, round to the hundredth. My open math will tell you what to round to. So hopefully you're all good with your rounding and when to round up and when to round down and all of that stuff, because they will tell you what to round to. All right, moving on. Let's calculate the mean of this data. So this is travel times in minutes to work for 7 employees of a startup web development company. So we're going to calculate the mean of this data. Hopefully you have a handy dandy calculator. Even if you're using your phone today, that's fine. On Thursday, you will probably want the fancy one. Next week, you will definitely want it, but Thursday, you'll probably want your TI 84 or whichever TI you happen to have. So I'm just gonna add them all together. I'm gonna add 23 plus 36 plus 23 plus 18 plus 5 is 26 plus 43 and divide by 7. Hey, there's not a huge delay this time. This is so much better than last time. So let's just do this. I got 24, about 24.9. So it's 24.857. Since the number after the 8 is a 5, we round up to 24.9. All right. So I'm going to put, this is a population, so I'm going to say that my mu is 24.9. My mu gets uglier and uglier the more I draw it. And if I sat there and did it like super slow, I probably could get it to look like the symbol on the screen, but it is what it is.
I have a question. My calculator right now, it says plot 1, plot 2, plot 3. How do I get it to be like normal?
Hit second mode.
Thank you.
You're welcome. Did it get you out of there?
Yeah, thanks.
Okay, yeah. Anytime you get stuck on any screen, second mode that quits whatever you're doing, and it'll put get you back to your regular screen. So wherever you get stuck, there's plenty of places to get stuck. Trust me. All right, let's move on. Maybe if I can get out of this. I'm stuck also. My eraser's stuck on. Okay, I guess I'm erasing things then. Okay. So now we're going to take a random sample of n equals 3 employees. So I would like each of you to just randomly choose 3 of those values and find the mean. Just each person randomly choose 3 of them. It does not matter which one or which 3. I'm going to do 23, 36, and 18. This is going to be my X bar. I should just be 25.7 because I'm only rounding to one more. Okay.
I made mine easy.
Huh?
I chose easy numbers, I guess, because it's
My X
clean.
bar is 25.7. What's yours?
28.
You did choose
I
these.
did 3 different numbers. I did 18, 43, and 23.
There you go. Anyone else want to share their X bar? So as you can see, even with just these two, they're very different. I mean, they're really different. Neither one is super close to 24.9. So it is always better if you can do the whole population to do the whole population. But if you can't,
Uh-oh. Okay, the echo's gone.
there we go. Yeah, so
Thanks.
the samples are good if that's all you have, but otherwise the population is good. I am going to tell you, so the hand in homework, it tells you to calculate a sample mean. Don't take a smaller sample of the values you're given. Just use those values, all of them, and calculate the mean of them. I'm only saying this because every single term I get 1 or 2 people that just take a smaller sample of those. All of those values, they are a sample. So the hand in homework, all of the values given to you are a sample. Okay.
Can you guys hear me?
I can hear you. Hi, Eddie.
Hey, how's it going? Sorry,
Hey.
I don't know. I got my phone and my laptop up right now. I can't hear anything on my laptop, so that was my echo there for a
There's a
second.
feedback loop.
Yep.
Yeah, sorry
I'm
about
so
that.
glad that you're able to hear now. You know, sometimes you got to do what you got to do, right?
Yeah.
All right. I'm going to move forward. Okay. I would like you to calculate the population mean of these test scores. So these are the first exam scores of 10 students enrolled in an introductory statistics class. So these are a population, so you're finding a mu. So the first thing I would like you to do is to compute the population mean here. Go ahead and average all of those values. Just use your fancy schmancy calculator. Go for it.
So I'm sorry I missed the first few minutes here. I was trying to keep up reading, but that was impossible. Is this just taking all of these scores and then dividing them by the sum total? Is that the mean?
Yes, so you're going to take all 10 of these scores, add them together, and then divide by 10.
Okay,
10 values there.
thank you.
Uh-huh.
Mu of 79 is what I got.
Okay. Said mu equals 79. I get confirmation. That'd be awesome. If anyone else wants to confirm, that's what they got.
Yes.
Okay, perfect. That's what I got also, so that's good. I can tell you though that because I do a ton of math, I probably make more math errors than any of y'all because I do a lot of math. The more math you do, the more errors you're going to make, but that's okay. Everyone has 5,000 bad math problems in them, and you got to get them out in order to get the good math.
So I guess I must have done this wrong. I took all the scores, added them up, and then divided by 10, and I got 642.8. So I must have done something wrong.
So probably what you did you put all of them added together and then right at the end put divided by 10 all in the same line?
Yes, ma'am.
Okay, the problem is you would need to put a parenthesis around the things you're adding together. Because all you did
Okay.
was added the first 9 and then added the last one divided by 10.
Okay.
So make sure you put parentheses around that numerator. That'll make the difference.
And that's just yeah, okay, I can see the parentheses above the 8 and 9, I'm assuming.
So you would put parenthesis, start open parenthesis, and then do 82 plus 77 plus 90, et cetera, et cetera, et cetera, plus 88, close parenthesis, divided by 10.
Okay.
Yeah, and that will get it there. So be really careful, and this is for future things as well. Whenever you are using a fraction and have calculations in the numerator and calculations in the denominator, parentheses are your friend.
Okay.
You can't overuse the parentheses. More the better. Okay, so now I would like each of you to randomly, I'm not going to do number 3, but each of you to randomly choose a sample of 4 and find your X bar. Find an X bar. Go ahead and choose any 4 numbers that you have that you want.
I got 78.75.
Okay. I'm going to put 78.8 just because I'm trying to stick with that rounded to the 10th place, but I'm not going to mark you down. Don't worry. Not that I'm being grading you on this.
80.5.
80.5.
Are we doing the same thing to find the X bar?
Yes,
We
but you're
divide
just
by.
you're
Okay.
taking 4 random ones. I got
Okay.
73.5.
I got
Okay, got it. I got
84.75.
Okay.
Show off.
All right. So was there one more?
I got 43.5, but my dogs are
Wow.
barking, so
So
I had to
something went
mute it.
wrong because something went wrong because it's lower than all these values. So something went wrong.
I got 80. I don't know if somebody already mentioned it.
Okay. So I mean, your average should be, it'll be somewhere between the smallest and largest. So it looks like our smallest is 62 and our largest is 94. So it would be somewhere between 62 and 94, but these are all over the place. Once again, it's evidence that the average is better because we have none of them. I mean, 78.8 is pretty close to 79, but other than that, they're kind of all over the place. Oh, 80.5 is pretty close, but they're kind of all over the place. 80 is pretty good. So.
I think what I did wrong is I didn't know I was using those scores. I made up my own numbers.
Oh, okay,
So,
that's fine.
so that makes sense.
I'm going to show you guys something really quick on the calculator. Hopefully I can get it to open up quickly. I have an emulator on my computer, if I can get to it. I have an emulator on my computer, and I'm going to try to log in real quick, and I'm going to show you some random numbers. Oh, yes, I agree.
And so while you're doing that, that was to find the mean for all of those numbers. Because I looked at the homework earlier and I was like, the mean, okay, that's the definition, I guess,
Yes.
is finding the average of all of those numbers.
Yes. Okay, so mean is your normal average, the average that we all basically know. So I'm going to show you that there's really no such thing as completely random. So obviously when you're grabbing numbers, we may say you're randomly choosing numbers, but our eyes generally, everybody has like some preference that their eyes go to. So if I get out of this. So if you want to have your calculator do it, so our calculators can choose random numbers for you. Let's say that I wanted to randomly choose 4 of those numbers. So I number them 1 through 10. So Michelle would be 1 and then Juan would be 10. And I want to choose 4 of them randomly. So if you hit the math button, you can see right here underneath alpha, there's the math button. Go over to prob. And then down to rand int no repeat. This is random integer, no repeat. So it's not going to repeat any numbers. So if I go down here, my lower value will be 1. My upper value is going to be 10 because remember I numbered them 1 through 10. And I want 4 of them. And so this is going to give me 4 numbers between 1 and 10, and it's not going to repeat them. So I got 10, 2, 6, and 5. So those would be the test scores that I would grab. The 10th one is Juan at 88. Rianne is 77. The 6th one was 68. And then the 5th one is 62. So those would be the random ones I would choose. So if you're taking a random sample, this is a really great way to get a random sample. And even though calculators use an algorithm, but still, this is as random as we're going to get. It's more random than us choosing numbers because when you chose your 4 numbers, did you try to not get them right next to each other? So so technically, look at this. We have a 6 and a 5. If it's truly random, sometimes they will be right next to each other. It's kind of interesting to think about our own biases and how we randomly choose things. All right. Me and my craziness, get back over here. All right. So I'm going to go to the next page. So let's talk about median now. So we got our average, our mean. We also have median. Median is the value that lies in the middle of our data when we arrange it in ascending order. So you would have to arrange them from smallest to largest, and then you just find that middle value. So here's how, these steps are very deep. I basically gave you the steps with just one sentence. So this is a lot of words for not saying much. First thing you do is you arrange the data in ascending order. So smallest to largest. Determine the number of observations that you have. So count how many you have. Determine the one that is in the middle of the data set. That's it. So you don't need to write the steps down. Once we practice it a couple of times, it'll be in your noggin. And Thursday, I'm going to show you some calculator functions that's going to do this super quick for you. Not today, but Thursday. All right, let's take a look. Unless anyone wants me to not move. Okay. So this is the same data that we had before. This is the minutes traveling to work of the 7 startup web development companies. Now we don't even have a symbol for median. We usually just put MED. It doesn't even have a symbol, but I'm going to rearrange these from smallest to largest. And I'm letting you know ahead of time, I'm really bad at rearranging things smallest to largest. Who knew that it was a skill? 5, 18, 23, 23, 26, 36, 43. Crossing things out helps, right? So I have 7 values here. Therefore, my center value, get a better color, my center value will be the 4th one. So this right here is the value in the center. So this is the median. It is that simple. It's just that value right there in the center. And when things are an even number, it takes a slight bit more skill, but still not a lot. Give you a second if you need it. Questions about medians so far?
Are we gonna do an example with an even number?
Yes, we are. We're going to do those test scores. Actually, we're not. We're going to add another person. So now the startup company hired a new employee. They travel 70 minutes to work. So we're going to get the median of our new data set. So once again, we're going to put them from smallest to largest. 5, 18, 23, 23, 26, 36, 43, and 70. All right, because I'm weird like that, I'm going to do a different color. So our middle, because we now have 8, our middle is in here. That separates the top half from the bottom half. So you just find the value that is smack dab in the middle of those 2 values. So you would do 23 plus 26, then divide it by 2. Now remember, if you put all of this in your calculator at once, use parentheses in the numerator. So that is exactly 24. Well, that's really ugly. Let's fix that. 24.5. So my median when I have this 8 values is the halfway between 23 and 26, which is 24.5.
So if you just take 23 and 26, and say 26 minus 23, you get 3, and half of that would be, oh, okay.
Yeah,
I got it.
that works. Whatever you need to do. I mean, a lot of times the numbers are super close together, or they're even the same number sometimes. So it's, it's whatever you need to do to find halfway between them is good. However your brain works. Other questions? All right. Not too shabby. This is not too bad at all. All right, let's move on. So this data in the table below represent remember, data is plural, so the data represent, really uncomfortable, the length in seconds of a random sample of songs released in 1970. Find the median length of the songs. So hopefully you have a piece of paper in front of you, and you can put these in order from shortest to longest and find that median. And I'm really bad at this, but I'm going to do it also. So go ahead and find the median. If you need to look up, look up. Otherwise, just please go ahead and do this. I'm running out of room, so I'm just going to go down below. I'll erase my marks for you. Okay.
I got 212.5.
However, there's only 9 there. there are 9 values. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is the number smack dab in the middle. So it would just be your 5th number. Because there's 9 values. It is an odd number. The odd numbers are
Okay.
the easy ones. It's okay. We'll get there. This is only the second example. We'll get there. So if it's an odd number, it is just whatever value's in the center. If it's an even number, that's when you need to split the difference.
Okay.
All right. Move on. Anyone need another moment? Okay. Let's try it with the test scores. Go ahead. This is one where it's an even number. So go ahead and put them in order and see if you can find the median here. How'd we do?
Same answer.
Yay. All right, so make sure you cut that in half. So this is really close to what it was for our when we did the mean. Remember the mean was 79. I think it was just 79, right? Let's see. Yeah, the mean was just 79. So the median's pretty darn close, and we'll talk about what that means in a couple minutes. But so that's pretty good. So 79.5, if you got that, go ahead and pat yourself on the back. Good job. Right. Moving on. So this is important. You will want this particular page right here. It's an important one. So I have students at the high school that will put like a little sticky note so they have a tab. But this is going to be important. I'm going to ask you a question that says something like to compare the median and the mean, and to tell me how it is skewed based on the comparison between those two values. So this is an important screen, that you're going to want to keep this. So if the mean and the median are roughly equal, so if they're really close to the same, like our test scores, the test scores that were really close to the same, then it is basically symmetric. So it doesn't have to be exactly the same, but if they're pretty close, we'll just say that it's symmetric or normal. Normal is another word. Normal, you can say bell-shaped, but basically we're going to have a nice pretty bell shape if they're normal or if they're about the same. If your mean is smaller than your median, you're going to be skewed left. Your data is going to be skewed left if the mean is smaller than the median. And it says substantially smaller. So our difference was 79.5 and 79. That's not substantial. If I would have had a mean of 63 and a median of 79.5, then that would have been skewed left. So if our mean is larger than the median, then we are skewed right. Once again, substantially larger is the rule of thumb here. So as long as you can explain yourself well, there is a bit of wiggle room there. Now, if you would have ended up with a median of the 79.5 and a mean of 95, and you tried to say that it was symmetric, I'd be like, no. But let's say you had a median of 79.5 and your mean was 82, and you decided to say that one was symmetric, and you say the mean and the median are roughly the same, so it's symmetric, I would give it to you. So there's a little bit of wiggle room there. There's no like hard and fast rule, like it's got to be within 2 or anything. And a lot of it also depends on how far apart the bottom and the top are. If you have a huge range of values and those are pretty close, then, just use your best judgment. Questions? All right. Anyone need a moment here? I'll give you a moment. Okay.
I'm good.
You're good? All right. Good to hear. Okay, so this is a whole lot. Don't worry, I'm not going to make you calculate these. We'll do the median. We can do the median from this. I don't think so. I think I already have it for you. I put these in values, the lowest to highest, but this is the asking price of homes for sale in Lincoln, Nebraska. I don't know when this was because I'm guessing they're probably a lot more than that right now. We've kind of home prices skyrocketed recently. So I'm going to find the mean and the median, and then we're going to do a histogram. So the mean price is 168,320. The median price is 148,700. So these are different by about $20,000. So we're going to say that the data is skewed right because there's about a $20,000 difference. So let's take a look at our histogram. Here's the histogram. The histogram definitely backs up our skewed right conjecture. Let's take a look over here. We've got this tail over here. Most of my homes are way over here. And I just made that really ugly. So this supports our conjecture that it is skewed right based on the difference. So you can make a histogram. Well, you guys know how to do it in Excel. You can do it on your calculator. It's not necessarily necessary. You can just use the mean and the median and compare those and talk about your skew. I would probably go to Excel before the calculator. I just don't like the way histograms look in the calculator. And besides Excel, you can copy and paste it into other things, which once you get your final project, don't worry, it's weeks away from that. Once you get your final project, you're going to probably be using Excel a lot to copy and paste things in. All right, let's move on. Let's talk about more shape of distribution. So don't worry, I'm not going to make you calculate the mean and the median here, but we're going to talk about the shape. So these are birth weights in pounds of 50 randomly sampled babies. There's some big babies on there. Look at that, 9.4. Is that the biggest one? I think so, 9.4 pounds. That's a big baby. And there's some little tiny ones. There's a 5.8 or anything smaller than that. Looks like 5.8 might be about the smallest. Some teeny babies. All right, let's move on. So this is from the book. I didn't want to make my own histogram, but I actually took this out of the textbook. So the mean and the median are pretty much right there next to each other in the they're pretty much the same or really close to the same. Look at where that bin is between 7.2 and 7.7 pounds. So we make the decision about which measure of central tendency we want to use, which measure of center. Generally, if there is no skew, the mean is the better measure that we can use. And a lot of it is because there's a lot more math and analysis we can do with the mean. So if possible, we want to use the mean. However, if we have skewed data, if we're skewed right or skewed left, you need to use the median. And a big reason for that is because unusual values or any kind of skew will drastically change our mean. So using the median, it's a stronger force against like outliers and unusual values. And so I'm going to talk about housing prices in a minute with that. I'm going to talk about mode first, though. So mode is our last measure of central tendency. We don't use it very much, but mode is just what occurs most frequently. So which value happens most. So that's just what the mode is. So we could have no mode, you can have one mode, or you can have more than one mode. We frequently hear things like bimodal. And I just like the word bimodal, so I will use it whenever I can because it's fun to say. And there's also unimodal, which is one mode, but I like saying bimodal more than unimodal. Some words are just fun. If no observation occurs more than once, we say the data has no mode. And there's not a fancy symbol for mode either, but we don't use mode a lot. It's just not something we do. Okay. The data on the next slide represents the vice presidents of the United States and their state of birth. It does not include Kamala Harris because I didn't want to redo my slide again, and it's kind of pretty right now. With all of the columns are the same size. So I would have to start a whole new column, and I'm not going to do that because I don't want to. So this gives me all of the states of birth of each of our vice presidents that we've had. I'm going to create a frequency table because it's going to be easier to look at. So here's my frequency table. And you can see that New York has had eight vice presidents born in New York. So our mode is New York because it is the one that is most frequently represented. And that's it. All that work just to say the mode is New York. You will be asked for mode occasionally, but we don't use it frequently. Questions, comments, queries, concerns? All right, next page. This is our last slide. This is a good page because it tells you when to use things. So we use the mean when we have quantitative data and when our frequency distribution is roughly symmetric. So if we are roughly symmetric, we will use mean. For median, it's going to divide our top 50% from our bottom 50%. And if we have our quantitative data and we are skewed left or skewed right, we will use median. Mode, we only use it if the most frequent observation is desired or if we have qualitative data. It's the only times we really use it. So I'm going to talk about using median because it's important to think about. So think about like real estate. This is when you usually hear median or income. Those are two different areas. Actually, I'm going to talk about income because I watched some news report and there was a news report that I watched and it talked about the average income for teachers in Oregon or for educators. They said educators. The average income for educators in Oregon was $98,000. And I was like, what the heck? I don't make anywhere near that. And I mean, I'm a 9th year teacher at Illinois Valley High School, and that is probably about the center of my career. So most teachers teach probably 20 years maybe. So I'm around the center of my teaching career. I don't make anywhere near $98,000. So what I determined is that most likely, since they said educators, they probably included like administrators, like principals and vice principals, and they make six figures. They really make a lot of money. Their starting salary is really close to $100,000 a year. So you get a couple of those administrators in there, and they're going to pull our data up. They're going to skew the data and they're going to drag that mean up with them. So if you're using mean, if you have a couple of high salaried people, or like if it's housing, a couple of really high priced homes, it's going to pull that mean up there. The mean is something called non-resistant, which means that if you have crazy high or crazy low values, it's going to affect the mean significantly. So the mean, crazy things happen when your data is skewed. So the median, it takes smack dab in the middle. So it's going to look at what is the middle income of all educators in Oregon, or what is the middle home value. That middle value is going to be a lot closer to the true middle than using the mean. And so the median is resistant, which means it is not majorly affected by outliers. So if I'm looking at like maybe a principal who's been a principal for 25 years and he makes $160,000, his income is not going to affect that average as much if I'm using the median. I'm guessing that the median educator income in Oregon is probably around $55,000 would be my guess. 55,000, maybe 60 at the most. So that's just my guess. I don't know though. I don't know how many new teachers we have, but probably somewhere in the 50,000s. All right. Any questions before I get on to a couple of homework problems that people have been questioning? Any questions on this lesson? Because 3.1 is done. All right, let's go to the homework. If I can find which way I got to swipe. So let's, is it gone? Is my internet gone? Did I close out of my browser? Maybe I did. Okay. Well, I'm going to open it back up again.
I guess the only thing I really think about or worry about, Guy Hughes here, is just knowing how to use my TI-84 calculator, like having like a tutorial or run through on that.
Whenever I
guess I
introduce
can just
anything
Google
new,
it.
I will help you with that. Whenever I introduce any
Okay.
new, and I don't know why my internet's not opening. Is it this screen right here that's causing the problem?
I bought my calculator because I'm committed.
You're committed. Good. You know, the
Committed.
calculator's super useful anyway. It really is. It is a great calculator. I love it. I keep learning new stuff. And because I've learned lots of new stuff, I'm probably going to pass it on to you guys. Every single term I teach this class, I learn something new. So you just watch out. I'll teach you guys all sorts of fun. So let's see if I can get logged into my open math. You guys don't go in this way. This is the teacher way, the back way. But I'm going to show you a couple of problems that have been questions that have been sent to me. And it's the same ones I get every term. So I thought I would come down here. So this problem right here, the Miller family budget. I've already received it twice this term, and I always receive it at least once. So this problem right here requires you to dig way back into your memory into when you were doing percents. So a long time ago, I believe it's a Math 20 topic. So long time ago, in Math 20, you did percents. I believe, I know I touched on it in Math 60 also when I used to teach that. But so the Millers, we know that the Millers spend $1,100 on housing. And we know that housing is about 45% of their income. We are looking for their total budget. We want to know how much total money the Millers make. So I'm going to go back to my other screen if I can get there. So this is for their housing. It's $1,100 and it's 45%. I don't know if your teacher taught it this way, but we know that percent and 100 go over here, and we have part over whole equals percent over 100. The way that I learned it when I was in school was is over of equals percent over 100. So I know that the $1,100 is 45% of what? So $1,100 is 45% of what? And so I have to calculate what this is. So you would just need to cross multiply. So I would have 45x equals 110000. Yes, there's other ways to do this. Yes, there's a way to get there simpler, but this is just your basic algorithm. So your part is 1100. 1100 is part of your budget. You want the whole budget. So you can just set up the proportion and solve it. So that is like the basics of how to solve that particular type of problem. Question on that? All right, let's jump back. Jump back. I'm going to go to the other type of problem that's been a struggle for people. So in 2.2, I've had several people, and each term I have several people who struggle with this. So I've had several people, I don't know if I want to do kittens or restaurants. Let's do tacos because I like tacos. Who doesn't like a taco? There's lots of people who don't like cats, but I don't know anybody that doesn't like a taco. So this restaurant recorded how many tacos were included in each order. This data is summarized in the histogram below. This one, they want to know what is the frequency of times an order included at least 6 tacos. So at least 6 tacos means 6 tacos or 7 or more tacos. So it would include these last 2 bars right here. So in this particular one, there's 6 times that we had 6 at least, or that we had 6 tacos. And then there were 6 times that we had 7 or more tacos. So I would just add those 2 together. 6 plus 6 is 12. Is that right? It is right. I'll do kittens. Here's kitties in a box. They don't even look happy. I do like kittens, but I don't want a kitten, but I like kittens. So nobody be offering me your kittens. So this wants to know, what is the frequency of a litter having at most 2 kittens? So at most 2 kittens would be 2 or fewer kittens. So there are in the 2 kittens box, there's 8. And in the 1, there's 7. So you just do 8 plus 7, which is 15. And you would get your answer. Questions? All right. That is all I have. And so we're currently still recording. So if anybody has any questions that they want on the recording, go ahead and ask those now. All right, I'm going to get out of the recording. I'm going to stop recording.